Now let's take a look at interactive jobs. An interactive job is a job where you get an interactive prompt after it begins. Let me give you an example. So in this case, I'm typing Salog, which is the version of SBatch for interactive jobs. I'm asking for 1 hour maximum runtime and then for 2 MPI tasks. After the job starts running, it will give me a prompt on one of the compute nodes allocated to my job. So I'm asking for 2 processes, and then these processes can be on 2 different nodes or on 1 node. And then once I get an interactive prompt, I will have access to a number of variables, Slurm variables starting with Slurm underscore. And these variables will actually give me more information about my job, and I can pass them to the code, etc. So let me give you an example. What I'm going to do is I will switch to the bash shell on the cluster. Here I'm logged in as user 120 on the training cluster. And I'm going to say Salog. And first, I'm not going to pass any parameters at all, just Salog. And I will hit enter. And that will start a Slurm job. Once it starts, I get an interactive prompt. Notice that the prompt changed for me. Before I was on node login 1 on the login node of the cluster, and now I am on node 1 on the cluster. So it says node 1 is ready for the job, and now I can run any code. So for example, if I have the serial code, let me compile it. Py.c is compiled into the executable called serial, and then I can actually run it here, right on the compute node. So this is great for testing because you actually have a dedicated compute node for the duration of the job. And then on this node, you can run the code. So you're not using resources on the login node. And that means that you're not slowing down the login node. So if you want to do debugging, if you want to test jobs, Salog command, interactive jobs, is really the preferred way to do that. Now I'm back to the login node. And what I will do, I will ask for 2 MPI tasks. So --n tasks is equal to 2. Salog --n tasks is equal to 2. And let's wait for the job to start. So it says node 1 ready for the job. And let's print the following variable, slurm underscore node list. And that will actually give me the list of nodes. So in this case, it's just a single node. And I have 2 processes. Both processes on this node are dedicated to my job. Let me quit this job and let me ask for, let's say, 6 MPI tasks. We'll wait for the job to start. So in this case, I actually have access to 3 nodes. So each node has 2 cores. I ask for 6 processes. So nodes 1, 2, and 3 are completely given to my job. And if I type echo slurm node list, it will tell me that nodes 1, 2, and 3 are now part of my job. And I have actually access to quite a lot of different Slurm variables. For example, I can print out the job ID, 21. I can print out the number of processes, 6, and so on. And here, if I compile an MPI code, let me say make MPI, it's actually compiled. I can actually start it with MPI run minus NP, number of processes, 6, because right now in this job I have 6 dedicated processes. And then I'm going to type the name of the executable, hit enter, and that will start the parallel MPI job. So it will start exactly the same copy of the code MPI on each of the 6 processes that are part of this job. And you can see calculating pi with 6 processes, and then each process prints its ID started, then computes a partial sum, and then process 0 will print the total sum. Notice that the order of processes here is actually not sequential, it's random. And that tells us that these are running in parallel. And here we have the answer. And by the way, if I type SQ, it will tell me that I'm running a job using 6 processes on 3 nodes. And because I did not ask for memory, actually the default memory per processor is 256 megabytes. And then if I want to submit, let's say, a hybrid job, what I'm going to do is also pass CPUs per task parameter. So let's just do that. I already quit the job. I'm back to the login node, and I'm going to say salog, and then ask for, let's say, 2 MPI tasks. And then inside each MPI task, I'm going to say CPUs per task, CPUs per task. And actually, let's do 3 MPI tasks, 3 MPI tasks, and then ask for 2 CPUs per task. I get an interactive prompt. I have 3 nodes in this job. And then if I type SQ, you'll actually see that in total, I have 6 CPUs. So 3 MPI tasks. And then each MPI task will use 2 CPU cores. This is actually not number of processes, but the number of MPI processes. So it's 3, and then 2 cores per task. Interactive jobs are really useful for testing and also for visualization, for post-processing data. And actually, in the visualization course in the summer school, I'm going to show you how to run client-server interactive GUI visualization using an interactive job on a cluster. I should mention that when you submit an interactive job with Salog, it will go to one of the specially designated interactive nodes. And if you want to see which interactive nodes you have, you can type sinfo and then graph for interactive nodes on the production cluster, not on the training cluster. And it will tell you how many interactive nodes you have, their names, and also their status, whether they're busy or idle or are down for maintenance, etc.